Good morning. Today we're going to be talking about the trig cofunctions and what their properties are. So we can use them to solve some problems. To start off, as always, we'll do some review. Pause the video, try and answer these, fellow men, and unpause whenever you're ready. All right, so for that first one, this is sol, ka, and lastly, toa. Anytime you're doing trig, it's always good to have this written somewhere on your paper so you can reference it. The next question is a throwback. This is really like old one. What are complementary angles? My hint was what do they have to add up to? And the word complementary is supposed to remind you it's two angles that add to 90. So it's like whenever you have complementary angles, you write down the number 90 and then it's fill in the blank. It's like some angle plus some other angle. So for example, calculate the complement for each of the given angles. Well, if one of the given angles is 60, what does this other one have to be so that it adds up to 90? Well, it has to be 30. 30 and 60 give you 90. Another way you can do it is instead of asking yourself, like, what does it have to add up to, you could take the 90 and just subtract whatever they give you. So what's the complement of 50? Well, it's 90 take away that 50, meaning 40. And lastly, that's where it's useful here. What's the complement of 47? I think it's 43, but just do 90 take away what they give you, 47. So 43. And that's, a basic review of some of the stuff we've been doing for the past couple of weeks, some stuff that we covered yesterday about complementary, and complementary angles are actually going to be a focus of today's lesson, because that, I don't know, maybe that co has something to do with it. Maybe it does. Maybe. Who knows? Okay. Today's lesson is kind of broken down into three parts. An opening question, which is meant to kind of get the brain juices going, give you some reference as to what we're doing today. I would definitely do that. And then here's the investigation. If you kind of want to just look at it, and I would do it. I think all of this is important, but this is not like the tool you're going to learn and use today. This is where that tool, that formula comes from. This is the most essential part here is this is where I summarize all the stuff. Like whenever you see this and this, you get to do something with this and this. That's kind of where it's heading towards, okay? All right, so let's come back here. Opening question, based on the diagram, fill in the appropriate ratio. That's this, that's a fraction. It's just something up here and something down there. For each of the given trig functions. So you're given sine, cosine, cosine, and sine. And if you'll remember, that's that and that. So and ka. Okay. So these look like the same pictures. Actually, let's just do one of them. So where angle A is the reference angle. That means this is what you're circling. So from there, this is the opposite. Find the right angle. That's the hypotenuse. And whatever's left is the adjacent. And if we're doing the sine, well, that's going to be opposite and hypotenuse. Sine is opposite on top, hypotenuse on the bottom. So I look here, it's 8 and 10. Sweet. Okay. Yeah, I guess let's do the cosine of A. Oh, I see. Yeah, I see what I did here. Let's do the cosine of A. That's supposed to, sine and cosine go with this picture. So the cosine of A is going to be, well, cosine is adjacent and hypotenuse. So that's going to be this 6 and that 10. So I'll put 6 and 10. 6 and 10. Okay, well, now our reference angle is no longer A. Our reference angle is B. So we're not going to use that picture at the top. I gave you another picture. This is the diagram when B is the reference angle. So your reference angle is now b. So we're not looking from here, we're looking from here, and that kind of changes it because the reference angle always points to the opposite, just like the 90 always points to the hypotenuse, and whatever's left is the adjacent. Okay, well, using this picture, now we're not going to use this one. Using the picture at the bottom where b is the reference angle, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So for the first one, it would be 8 over 10, because that's the adjacent over the hypotenuse. And then for the bottom one, for sine of b, it would be 6 over 10. And what do you notice about these ratios? Let's kind of clean this up. Let's just get rid of all this other stuff. That's a fancy way to say, what do you know about their value? Like, what do you know about what they kind of equal? And you can see here, these ratios are the same. And same thing here. These ratios are the same. It's 8 over 10 for sine of A and 8 over 10 for cosine of B. It's the same triangle. This triangle is the same as this one. It's the same numbers, same angles, everything. It's just depending on how you look at it, you'll get different ways to say the same thing. So what do you notice about the above ratios? Some are the same. Can you make an equation? Absolutely, I can. I could say 8 over 10 is the same as 8 over 10. And I guess what I'm kind of like fishing for is that red 8 over 10 is the same as that blue 8 over 10. And that blue 8 over 10 is that. That's really the cosine of B. And that red 8 over 10 is really the sine of A. So I could kind of cut out this middle stuff and just say the sine of A is the same as the cosine of B. That's one way I could look at this. Another way I could look at it is, well, 6 and 10 is the same as 6 over 10, so sine of B is the same as cosine of A. The cosine of A is the same as the sine of B. Okay. What do the equations look like? Well, each equation has sine and cosine in it. You know, maybe they get swapped around, cosine and sine. So you're going to have sine and cosine on one side, and then each equation has an A and a B. Has an A and a B. And what A and B represent in the triangle is the non-90 degree angle. All right, it's this angle and this angle. It does not use angle C. Okay, let's just keep on going. So using a calculator, you're just going to type in these things. You're filling in this table. It would be like, do the sine of 60, do the sine of 30. Next, do the cosine of 60, do the cosine of 30. So you would just type it into a calculator, sine 60, and then write down your answer. So 0.866 right there. And then beneath it would be the sine of 30, which is 0.5. And the reason why you're doing that is there is a series of questions. There will be a pattern that emerges. We want you to like look at that total data and see if you can figure out what's going on. So pause the video, take, I don't know, 5-10 minutes, try filling it in on your own, and when you're done, you can come back and see what we got. So now that you've unpaused the video, I'm just going to paste in the values to that table, just because I think it would be tedious to do by hand. And we'll go through some of these questions. What do you notice? Are there any patterns? Well, that means I'm going to look for a pattern. It's like, do I see 0.866 show up again? Yeah, I see it here. Okay. Do I see 0.5 show up again? Yeah, I see it down there. There's no pattern I can see with tangent. Tangent doesn't have anything go on. So I see like the sine of that equals the cosine of that. So the sine of 60 is the same as the cosine of 30, and vice versa. The sine of 30, which is 0.5, is the same as the cosine of 60, which is 0.5. Okay, so sometimes sine equals cosine, and sometimes cosine equals sine, but there's no pattern going on with tangent. Let's see if that still holds true. So the sine of 50 is 0.766. Well, what about the cosine of 40? Yeah, that's also 0.766. What happens if we swap it? Well, the sine of 40 is 0.642, and the cosine of the other angle, 50, is 0.642 as well. It's the same. Once again, no pattern with tangent. And that's what's happening here. The sine of this top angle is always going to be the same as the cosine of the bottom angle. And you can swap them. You could instead do the sine of the bottom, the sine of 43. That will have to be the sine as the same as the cosine of the other angle. And that's where we kind of want to bring this back to where we started our lesson. This word is sine, it's the function, and notice that cosine, it's sine, but it's got a co in front of it. And that co is meant to remind you that they are cofunctions. They share something in common. And not only are they cofunctions, they do something special. So yeah, there's a pattern. We kind of talked it out. Could you write an equation? Yeah, we could. We could say the sine of 60 has to be the same as the cosine of 30. That's just one example we could do. Let's pick one from here, and we'll do it the other way now. We'll do the sine, and I'll use the abbreviation of 40. So I am doing this. I'm saying 0.642, the sine of 40, is the same as the cosine of 50. The cosine of 50, which is also 0.642. We could write more, yeah. But what do we notice about the angles that are paired up? What do you notice about, now I'm just going to erase this stuff because we don't even need it. Let's focus on the good things. What do you notice about these angles? What do they add up to? Well, 60 and 30 is 90. Okay, what do you notice about these angles, 50 and 40? They also add to 90. And I guarantee you that last pair, 47 and 43, add up to 90. And I think that's how we started this lesson, is we asked you, find the, there's that word, find the complement of 60, find the complement of 50, find the complement of 47, because that's where it was coming back. And cofunction is really coming back to these complementary functions. Sine has to be equal to its complement, cosine, when the angles do what? When the angles are complementary. The only time these things are equal to each other is when those angles add to 90. That's why this works. That's why I know the sine of 40 has to be the same as the complementary function, cosine, with the complement of 40, 50. So here's another example you could do. If I said the sine of 20, I know that has to be equal to the complementary function, cosine, of the complement of 20. So the complement of 20, 90 take away 20, is 70. That's how I know those values are going to be the same. And I'll even show you real quick. The sine of 20 will be the same as the cosine of the complement. And it always works. You could pick really weird numbers like the sine of 1. The complement of a 1-degree angle is 89, and the complementary function of sine is cosine. So cosine 89 will be the same. And that's today's lesson. That's the formula. All right. Sine and cosine are cofunctions. Cofunctions take different inputs and produce equal outputs. The theorem for today, which we kind of just covered, is that the angles of cofunctions are always complementary. They always add to 90. And how do you use this? Well, for example, the sine of A will always equal the cosine of B. Then that means that angle A and angle B have to add up to 90. And where you'll see this, so I'll do these 3 model problems for you, and then you'll go on your own. It's like, okay, well, as soon as I see sine and cosine and they're equal, I'm immediately saying, okay, well then these angles have to add to 90. They have to be complementary. That's what's going on here. So it's like, well, 80 plus, we'll call this x, must equal 90. And then you could do the algebra. Take away 80 from both sides. X equals 10. Boom. So 10 is what has to go in that blank. And I know a lot of you could just be like, well, what's 90 take away 80? And you could do that here. You could be like, okay, well, if cosine is here, I know it has to be equal to the cofunction. What's the cofunction of cosine? What's the opposite of cosine? It's sine. That's how I know to write sine. Well, if I see 5 here, I have to write the complement of 5. I have to write the thing that when I add it to 5, I get 90. So this will be sine of 85. Cosine of 5 is equal to the sine of 85. Boom. Where it gets harder, this is probably the best example I'm going to give you is here. This is like what most of these problems are going to look like. It's you look for sine equals cosine, and then you're immediately making an equation. You're going to say, okay, well now that I have sine equal to cosine, that allows me, right, the sine equal to cosine lets me write out 90. I know that whatever's in sine and whatever's in cosine, those things, so what's in there is x, and the other thing that's in there is x plus 60. Those things have to add up to 90. And now you have an equation that you could solve. You could say, well, x and x is 2x, drop down that 60 equals 90, subtract the 60, you're going to get 2x equals 30, divide both sides by 2, x equals 15. That doesn't mean the angle is 15, it means that x is 15. So if we come back here, what are these angles that go into sine and what are these angles that go into cosine? Well, for sine it's easy, it's 15. And then this is 15 plus 60, this is 75. But I could have told you that originally because you could just do, what's the complement of 15? Sorry. 90 take away 15. That's how I knew it was going to be 75. And that's what we're asking you to practice today, is this stuff here. So try 1 through 8. I mean, I think if you do 6 of them, I think you'll be fine today. You get the gist of it. 8's kind of hard, I'll say that. But basically what you're looking for is sine equals cosine. That means you write 90 down. And then the other stuff is just whatever's in the angles, whatever's written down next to sine and cosine, you add them together. It's, okay, well, x plus 30, and then the other one is you add it plus x. You just add it. Make equations, solve them, turn it in, earn the grade. Thank you so much. We'll see you tomorrow.